What? Hey, Monkey Cat, what are you doing? Hey guys, this is my cat Monkey Girl. She loves being on camera, don't you? Yes, you're just really good. Okay, alright. She's like, not today. So this is my workshop here. Let's go through. And this is my living area. This is my e-bike. And what we're working on here, my buddy Hiram and I, Hiram sent me these materials to recycle. And what we have here is some high perm material that would come out of a computer. This is part of a hard drive or some other part, but this is high permeable material. Now these are the magnets that definitely came from the hard drive. And what we're going to do is we're going to use these as a field core for an AC motor. And this is going to be a magnetic motor. This is going to be the magnetic core here. And we're going to put a, we're going to do shade poles on here. This has a little notch. You can see that. There's a notch there that'll be perfect to put a loop of copper. And that copper will actually slow down the magnetic field, so it doesn't just cut the field strength. There's an element called bismuth that's very diamagnetic, which will actually cut the field strength, but the entire magnetic field goes through instantly. So what will happen is the motor might start searching, but if you put a loop of copper, copper's the only metal that I know for sure has this effect that will actually slow and repel the magnetic field. So it's some sort of a magnetic action, paramagnetism maybe, or something like this that the copper has. So it doesn't have really so much to do with blocking the magnetic field. It actually slows it down, and it's not Lenz's law, because other conductors like silver, which is more conductive than copper, does not do this. You can't use silver loop here. You have to use a copper loop. Okay, so it's not Lenz's law, because we're using the same applied field and the same current and everything else, but the copper is the only one that works. So that argument now is settled. I'm not going to talk about that anymore. But think about it. You could use copper in a magnetic motor to slow parts of it down. Okay, hint hint, for people that want to make their own magnetic motors that are self-running maybe. I've never got one to self-run, but even if I did, I probably wouldn't tell anybody about it. Uh-oh, this thing flipped over on me. Hold on, I'm going to set the camera down and put this back together. These magnets can be very frustrating. They're very powerful. So these magnets came out of the hard drives that Hiram took apart, and they're very powerful. These are N52s, which is it's about the strongest you can buy without a special license or something. So these all go end to end. They'll attach end to end because of they have alternate polarity. So it's north, south, north, south, north, south, north, south. But what happens when you arrange magnets like this is you have a weak area in the middle, and you have a very strong point here, a very powerful point here, a very powerful point over here. Hopefully the camera is focused on where I'm aiming. So what happens is this forms basically a Hallback array, but you see this isn't quite, it's not quite circular. So what I'm going to have to do to fit this inside of my core, it's going to be a thin, low profile motor. So what I need to do is I need to figure the average distance between here and here, and then when I figure that average distance, that will be my diameter. And then I'll just use a compass, and I'll use the Pythagorean theorem and pi to calculate the correct radius to use my compass. And I'll take a compass and I'll just make a circle that fits in there, and that will form this into a circle. I'll just put maybe a little piece of plywood or something and stiffen it with some epoxy, and then I'll have a shaft, and I'll probably just use a carbon fiber Probably just use a carbon fiber shaft since I have several of these carbon fiber rods around. I'll set this down now. Grab the camera. So anyhow, once I figure out the right diameter or radius here, and I can use my compass, I'll make a circle and cut it out, and I'll glue that in there and glue these on there with epoxy so that this won't come apart at high speed. And maybe even put some sort of reinforcement on there, like some fiberglass mesh tape that they use for drywall. Just put that in there and put some epoxy. That will make that really strong and rigid so it doesn't fly apart at high speed, because this may end up being a fairly high speed motor. But we're going to put AC windings on here next, and then we'll mount this. We'll have to mount these field poles somehow. I'll probably just use, again, plywood and just cut it out, and I'll cut out holes for the windings on there. And then I'll just try to wrap that nicely and paint it all. And I suppose I'll just maybe make like a nice little stand here and just have a couple of feet on either end and sort of try to make it artistic looking. But the end result is that the field poles, instead of having it at right angles where you get maximum counter induction, the wiring will be in the same direction as the field is going across, and all the lines of the inductor are in parallel to it. So that's where you get the minimum amount of induction. So the counter motive force should be minimized. But what's going to happen is when you have these high power points of the Halbach array, as they come around, they're going to cut through the maximum amount of induction. So this is what John Bedini was doing. This is basically what Paul Babcock is doing with the ring motor. He has a ring shaped motor. Tesla also was doing this with ring shapes. But what's going to happen is this is going to be very powerful as a generator, and it's also going to be very powerful as a motor, because almost all of the power that goes in here is simply going to be pushing on the magnets. It's going to be pushing or pulling on the magnets, and it's going to have alternating fields. So I'm just going to do a straight winding. I don't have to alternate the windings because the alternating current will pull back and forth. We just have to have the shade poles and this Halbach array, and then of course we'll figure out the best air gap for this to get it to spin. It may or may not want to spin right away because it's not a squirrel cage, it's only 4 poles, so it may even need a kickstart. But once this gets going, if it works, it should make a really high speed motor. It may fly apart too, which would be exciting, you know, have a little explosion there, but maybe not. You know, it should settle down at whatever that maximum, you know, 60 cycles AC coming in there, so it's going to settle down at whatever that maximum, you know, maybe 3,000 RPM or less than that even. But at the same time, it should be exciting, and what I'm going to do is I'm going to post this on eBay, and any money I get from it, I'll send that to Hiram so he can send me some more magnets. You know, we're trying to just earn a little bit of income doing this, but mostly this is just for my viewers on Patreon and for my supporters on the Real Free Energy Facebook page. I appreciate all of your help, and I really couldn't make it without you guys. The income that I get from Patreon, that's the only income I have. This is what I do for a living. I'm an inventor, I'm a creator, and I try to be an artist. Maybe not the best in the world, but I will try to make this a pretty looking motor and an effective motor that someone could use for a project, and offer it for sale on eBay. So this won't be patentable, because this is just basically, this is same like the pump in your washing machine. Your dishwasher at home has an AC motor with a magnetic core. That's very much the same sort of setup. So anyhow, I guess that's all for this time. This is part 2 of the magnetic motor open source. We're going to just show all of this. When I come back, hopefully I'll have a core put in here and a shaft, and I'll go ahead and mount these 2 field poles onto some plywood or something, and we'll let that be the next video. Alright guys, thanks for watching.